team called the iPhone Elite team. When I came to the iPhone Dev team, I was more interested in baseband, although nowadays I do some jailbreak stuff too. I was fortunate to be tech editor for this iOS Hacker's Handbook, which came out a few weeks ago. Some of the authors of that book are also here this week.
Development process and has gained a lot of security features over time, so it has grown to a really well-secured operating system, and it's considered to be one of the most secured OSs around. Yeah, we skip the signature checks and just load the patched images and can this way run a custom RAM disk. So we just lose all these authentication steps and the whole boot chain. Yeah, for Corona, we have the first thing is we disable the aerospace layout randomization by just setting a specific launch D key on, so that on startup we just have this feature disabled. Code signing.
It was a short-lived bug, only ran for maybe 2 years for the most part. There was really a lot of them. I'm not quite sure. I was pretty amazed when Cyril brought this to me because I never got to work on a format string bug before. Basically, it shows the code of the bug. It was actually in the warning function and error function. So basically, any warnings or errors printed to the log would trigger this format string.
To exploit, to do a jailbreak, you see that we need to patch the security features of it somehow. So basically, jailbreaking consists of removing certain features, security features of the kernel to let the user execute custom unsigned code. Also, it adds the ability to run code outside of the container sandbox and not complying on App Store's application rules. This is a slide explaining the code signing basics, the mandatory code signing, because iOS kernel will refuse to execute unsigned code in different ways, because first it crashed the kernel, when I tried to mount a specific image that I modified. But I don't really understand the bug. I've walked into the source code of OS X anywhere and couldn't understand it. This is quite complicated. So here is HFS Plus in figures. It appeared with macOS X 10.4. And it has to be done also out of the Raccoon sandbox. David will explain this afterwards. And this is required. And one little trick we used to just keep the sandbox at boot time is just to patch the Raccoon binary and just change 1 byte to modify the Raccoon profile to just to nothing. Yeah, in fact, to nothing. You just skipped the profile by just modifying the entitlements blob of the Mac O that weirdly were not checked by the.
The problem is we need a new injection vector so we can gain the initial code execution. The kernel files have to be copied onto the root file system so they can launch every time on boot through a launch daemon.
Get some vital information for our exploit. What we do now is we need to somehow crash something, and this crash must happen and is at a specific place in the jailbreak process. Since we cannot rely on waiting for a program to crash, we actually have to force something to crash. And the easiest way to do this is actually to crash one of the services.
And As Josh and Nikias have showed you, that we now have the ability to, on a stock A5 device, to execute Raccoon with a configuration file of our choosing. Unfortunately, the stock copy of Raccoon is still sandbox, and in order to launch the kernel exploit, we'll need to break out the sandbox. So this shows you how. So what is the sandbox? It's codenamed Seatbelt. It's based off the trusted BSD mandatory access framework, or at least part of it is. It's actually split into two different parts. One is a kernel extension called sandbox.kext, and the other is this mandatory access control. And sandbox.kext is actually the brains of the sandbox, whereas the Mac framework is how